Today we're going to use the predictions, so that will require a few steps in order to first create the equation that you guys have learned before in Unit 2, and then we're going to also use skills from Unit 2 to predict, use the line of best fit to predict. So lines of best fit generalize data, and they represent an average of the data. And that's because I'm constantly telling you guys, when you draw your line, make sure it goes through the middle of the data so that there's about an equal amount of dots on the left side as there are on the right side. And of course, as many points that you can go through, the better. It goes through the middle of data. Lines of best fit can be modeled with linear equations. So we're going to revisit Unit 2 right now. I taught you guys how to write equations from graphs, but now we're going to write equations on a graph, and you'll see that I gave them to you. So we have our line. We have the 2 points that I've labeled, 4, 8, 8, 5. So this will be x and y, x and y. It's always good to label your points just to remember. Our first step is to find the slope from the points. So you'll see our box. I'm going to put the first point in, which is 4, 8, and the second point in, which is 8, 5. And then I'm going to find the distance between my x values, which is plus 4, and the distance between my y values, which is minus 3. The last step is to then put my y over x, and I now have my slope. It makes sense that this is a negative slope because the line is going down from left to right. Now we're going to use one of these points, the slope we just found, to find the y-intercept. So find the y-intercept using the slope and a point given. So this is the y equals mx plus b equation, so I'm just going to label those letters underneath to remind us where to put stuff. I'm going to use the first coordinate. It doesn't matter if you used the second coordinate, you'll get the same answer. I'm just choosing to use the first. So for my y value, I'm going to put 8, because that is in the 8 column, or the y column. For slope, I'm going to put what I found, negative 3 over 4. And then for my x, I'm going to put 4. And I'm going to turn this into a fraction, because whenever I multiply, I like to multiply a fraction by a fraction so that I remember to multiply across. Now I'm going to, so again, multiply across. Negative 3 times 4 becomes negative 12. 4 times 1 becomes 4. I'm going to bring down the equal, bring down the 8, and bring down plus b. My next step is to divide. Negative 12 divided by 4 is negative 3. And my last step is to add 3 on both sides, and therefore equals 11, or my y-intercept equals 11, which means the graph crosses at 11. And we could have even just pulled that information straight from the graph. So you'll see that they're matching. Y-intercept and y-intercept. The third step is to create the equation. So I have y equals negative 3/4 for my slope times x plus 11. Now you can also use this equation to make predictions about things not seen on the graph. So for example, we're looking at a car value and the time since it was purchased. So if I'm reading this graph, at 0 years, the car is worth $11,000. And if I go back to my slope, it means that every year the car gets older, increases in value by 3/4. So I can see the value of the car up until year 13. But let's say I wanted to know year 14. I can't see that. So in order to figure out what the car's value would be, or the y value would be at year 14, which is an x value, I'm going to plug 14 into x and solve for y. So I'm going to put this in my calculator because 3 times 14 is a pretty big number. So we have negative 3 times 14, which gives us negative 42. Four times 1 is 4, plus 11. And then I'm going to use my calculator again to divide. I'm okay with decimals for this problem. So negative 42 divided by 4 gives me negative 10.5. And I know that negative 10.5 plus 11, or 11 minus 10.5, which is how I would switch these in my brain to make the subtraction easier, would just be 0.5. So when we go back to the graph, it's saying this is the value in thousands of dollars. So we have 11,000, and then we have 4,000, and at this point it's 5,000. And now you're going to see that the line, if it continues below 1, so that means it's no longer in the thousands, it's going down to the hundreds. So when I read this decimal, I know that 0.5 means the car is worth $500 after 14 years.